All right, these are the answers to the Chapter 5 mini review. We're taking the derivative here and using product rule. So it's not going to fit on this line. We'll do it below here. It should have been 2x, leave the second function alone, plus, now leave the first function alone, times the derivative of e to the x, which is e to the x. You can factor out an x and e to the x. So sometimes they'll do that on a multiple choice. They'll pull that out and leave it with 2 plus x left over. Both of these are the same and good. It just depends on which one they want you to go to. Right? Part B wants us to integrate this. We'll probably need a u sub for it, unless you want to think backwards on it. U is going to be 5x plus 3, the whole bottom. So du will be 5 dx, which means dx will be du divided by 5. So when I come back to do that, I'm going to have the integral of 1 over u times dx, which is du over 5. Now, I'm just going to pull that over 5 out front, make that a 1/5. All right. Then when I integrate, anytime you integrate 1 over u, it goes to natural log of absolute value of what was inside. So this will be absolute value of u, but u was 5x plus 3. So I'll just put that back in, plus c. For letter C, just a log rule. Understand that I can bring this 2 up, make it the exponent of the 4, and so 4 squared would be 16. Right? No big deal. For letter D, I'm going to use a quotient rule here. So quotient rule says take the bottom times the derivative of the top. Derivative of the top is going to be a chain rule. We're going to let the derivative of E is just itself, so everything stays the same, times the derivative of 6x squared, which is 12x. Okay, minus the top, e to the 6x squared, times the derivative of the bottom, which is 1 over bottom squared. So that would be our derivative right there. E, we're integrating, and this is going to be a u sub here. 1 minus e to the x is going to be our u. And our du will be the derivative of this, which would be a negative e to the x dx. All right, so that means dx is du over negative e to the x. When I come back to this, I'll have the integral of e to the x times the square root of what now is u times dx, which is du over negative e to the x. The e to the x's cancel. I can bring this negative out. We're going to integrate u. Integrate u to the 1/2. We'll go to u to the 3/2 over 3/2 plus c. If I flip this over, I'm going to get a negative 2/3 times u, which is 1 minus e to the x to the 3/2 plus c. All right. And then we get to f. We're taking the derivative. This is a chain rule. So we take the derivative of the outside. Derivative of natural log is 1 over whatever is inside of it times the derivative of what's inside of it, which is cosine. You can leave it like that, or you can put the cosine on top, and cosine over sine is cotangent. Either one of those is fine. Okay. We get to g, and g says f and g are inverse functions, and they want us to find, they would kind of explain what we would know based off of this. So if I have f and I have g, I know the point 2, 8 is on f. That means the point 8, 2 is on g. And I'm told that f prime of 2 is negative 3. So negative 3 is the slope of f. So if I take the reciprocal, the slope at g at that same point is negative 1/3. So we have these opposite points here, all right, that kind of play out. And so what does this tell me? That g prime of 8, the x value, is negative 1/3. If you keep it in this format, kind of with that opposite idea, then that's your best bet for getting that right. All right, integrating here, this is going to be a u sub. U is going to be the whole bottom, 49 plus 4x squared. Du then would be 8x dx, which means dx will be du over 8x. Okay, come on back. I got the integral of x over u times dx, which is du over 8x. The x's cancel like we want. We can pull that 8 out front. So we're going to have 1/8 times the integral of 1 over u, which is natural log of u. The natural log of the absolute value of 49 plus 4x squared plus c. Now technically, because 49 plus 4x squared will always be positive, you wouldn't need the absolute value on it, but it doesn't hurt if you do. Okay. Then letter B, I've got the the integral of this, and so I'm going to let u be negative x to the fourth. That means du is negative 4x cubed dx. That means dx is du over negative 4x cubed. Okay, come back here. I've got 4x cubed times e to the u times du over negative 4x cubed. So these cancel except for the negative. I have a negative out here. I'm going to have the integral of e to the u, which is e to the u, or e to the negative x to the fourth, and then plus c. So that'll be my answer there. And then on this one here, it says f and g are inverse functions. What's the value of g prime negative 4 given this? So again, let's make our different functions here. We want g prime negative 4. That means negative 4 is the x value for g. That makes it the y value for f. All right. And so I want to know what would I have to put into f in order to get negative 4 for an answer. So if I were to put, say, negative 1 in, I would get negative 1 minus 2 minus 1. That would give me negative 4. So negative 1 is my value there. Okay. Now what I want to know is, well, what is the slope of the tangent line to f at negative 1? And so I'm going to take the derivative here, just 5x to the fourth plus 2. I'm going to put negative 1 into that. It's going to give me 5 plus 2 or 7. That means the slope of the tangent line on g is 1/7, the reciprocal. And so that's the value of g prime negative 4. It's 1/7. Okay. On this one here, we're given a table of values, and it says find the what does g prime 1 equal? So again, I think it's best, even with a table, especially with a table, to set it up in this format. We want g prime 1. So I want to know, when does the f function equal 1? The f function equals 1 when x is 7. What was the derivative of f at that point? The derivative was 3. So that was our slope, right? So what would be the slope over here? The slope over here would be 1/3. Find an equation tangent for g when x is 5. So again, here's f, here's g. We're going to put 5 in for x. That means it was the y value of f. So when did f equal 5? Well, that was when x was 3. So that means 0.53 is g. That's the point of tangency we're going to use in just a second. What was the slope of the tangent line at f over here? That was 7. So the slope of g would be 1/7. Right? So there's our information. Y minus y equals slope times x minus x. That'd be our answer. Okay. And then the last one here wants us to find the equation of a tangent line to the point 2, 1. So what we're going to do is find the derivative of this. We're going to do implicit. It's 2x minus 3 times the derivative of natural log of y. That's 1 over y times dy dx. Plus 2y times dy dx equals 0. Okay. Now what I would recommend is just go ahead and put 2, 1 in for here. Put 2 in for x and 1 in for y. So if you do that, you're going to get 4 minus 3 times 1 times dy dx plus 2 times 1 times dy dx equals 0. This is 4 minus dy dx equals 0. Add that over, and there's our slope. Dy dx is equal to 4 at that point. Okay, so now we have our point 2, 1. We have our slope 4. Y minus y equals slope times x minus x. And there's our answer.